All right, here we go. So, just to recap on what Ms. V covered with you guys yesterday. Yesterday, you guys did an introduction in regards to equations being compared to a seesaw, right? Okay. And that same idea applies to scales. Have you guys seen these kind of scales? Yes? Look up to the screen. Yeah, I've seen some of those at the some of the jewelry stores. They still have some of them. Cardenas and Food for Less have the ones that it's only one now, and they have more like digital and stuff like that, or they have numbers showing the weights. But back then, they used to use this kind of scale. And what they did, when they would put weight here, it would drop like so until we placed the same amount of weight on the other side so it can balance out. Is that correct? Now, this is very similar to what you saw yesterday with that seesaw. Is that correct? Remember with the grams? You guys remember? Yeah? All right. So, and we said that that the seesaw, if it was on a table such as this, then by looking at the bar when it's balanced and by looking at the edge of the table, then that's where we got the equal sign. You guys see the equal sign forming? Yes. All right. Now, with that same idea, though, check this out. Let's say we have this. What's on this side of the scale? 8. What's on this side right now? 0. Okay. Where was the original bar of the scale? It was about right there. Is that correct? Do you guys see what it formed? Do you guys see it? Boom. So therefore, that is why inequalities are not equations. Equations is when it's balanced. Inequalities is when it's not balanced. And hopefully this year we're going to take care of that. I remember that some of your teachers taught you the alligator, and the alligator eats blah, blah, blah. I'm like, what? What are you talking about? That worked back then. Now we need to understand what we're looking at in regards to a scale. Does that make sense? All right. So with that said, you guys never got taught the alligator? Or the Pac-Man? A duck? Bam. All right. So the duck wanted to eat more food or something like that? Oh, I see. I got you. All right. Here we go. Let's read the objective. I can solve and graph one variable equation. Read together. 1, 2, 3. I can solve and graph one variable equation. And if you notice, I already gave you the objective at the bottom. It's already in there. Turn to your neighbor, let them know what is the objective. I mean, not the objective, the concept for today, the concept. So, yeah, so we're still on one variable equations, but like everything, guys, everything escalates pretty quick. So that's why I need to kind of review some of the steps that Ms. V covered with you guys yesterday. I'm just adding one more step. And if you notice on the notes underneath, after the Freire model, we know what the one variable equations are. So just to recap on yesterday what Ms. V showed you guys. She showed you guys a definition. So just to match it to mine, look up, please. I want you to underline, if you have a red pen or with your pencil, I want you to underline where it says two expressions equal to each other. That's probably the simplest way of thinking of an equation. Two expressions equal to each other. What is an equation? Two expressions equal to each other. Does that make sense? Now, let's see if it's true by looking at an example. Look at this one. I'm going to circle this one by itself. Look at this piece by itself. Is this by itself an expression? Yes. Is this 3 an expression? Yes. And are they both equal to each other? Yes, there it is. Let me show you another one. Look up to the screen, please. Is this an expression? Yes. Is this an expression? Yes. Are they equal to each other? Yes. Expression, expression, equal to each other? Yes. Do we understand what they look like now? Yes, we saw that since yesterday. And then they gave you some non-examples similar to these. Write these down, please. Non-examples. X plus 5 minus 25, 12 greater than x minus 8, x squared plus 5 equals 30, and 4x plus 6 equals negative 2y. As you're writing them down, think to yourself without saying it out loud why each one of those is not a one variable equation. All right, talk it over with your neighbor why each one of those is not a one variable equation. Rachel, why is this one not a one variable equation? Doesn't have an equal sign. So what is this one called if it doesn't have an equal sign? Expression, that is correct. Pass someone? Manny, why is this one not a one variable equation? It's an inequality. Bam. Inequality. Pass someone? Tony. Okay. Watch. Look at all these. And look at this one. What's so different about that? Exponent is what? Okay. So yeah, the exponent being 2. That would be a quadratic equation. We're not in quadratic equations. Technically, it is a one variable because it has one variable. But right now, we're working with one variables that have an exponent of 1. This one is greater than 1. Does everybody see that? And the last one, Tony, pass someone. Armando, why is that not a one variable equation? Let me give you a hint. Armando, why is that not a one variable equation? 2 variables. So what would be a name that we would give this one, Audrey? Bam, Audrey, that is correct, a 2 variable equation. And we will get into those later on. So for right now, you take a picture of this, you're going to send it to your BFF, and you're going to tell them, one variable equations are what? Hashtag what, hashtag what, hashtag what. One variable equations are hashtag what. Write it in there. Don't say it out loud to yourself. One variable equations are hashtag what. Okay, Katya. Hashtag no exponents. Okay. Hashtag Raymond. One variable. Bam. And the last one, hashtag what, Jesse? What is it? Crazy? A what? Oh, equations. Okay, my bad. Equations. All right, and you make up your own, right? All right, steps. Now, underneath there, I gave you 4 steps, which is adding one more from what you did yesterday. Here we go. It says simplify each side of the equation. The reason I'm being very specific here because we're getting, like I said, we're going to get into multi-step equations, and you need to know exactly what to do at each step, okay? Simplify each side of the equation. Start with the grouping symbols and combining like terms. Step 2, isolate the variable by using inverse operations. Have we been doing that? Yes. Plot your solution on the real number line. Have you been doing that? Yes. And check your solution by substituting the value of the variable into the original equation. So now you're going to memorize that. You have 30 seconds. Just kidding. That's a lot, right? However, what if we do this? Let's shorten it. Step 1, circle the first word. Step 2, circle the first word. Step 3, circle the first word. And step 4, circle the first word. Simplify. Isolate. Isolate means to leave by itself. Plot and check. Simplify, isolate, plot, 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 check. So for tonight, what are you going to do in your home plate? That is correct. I want to see all those steps for tonight's home plate. Okay? So here we go. So where were we? Don't copy this. Look up to the screen. This is what you did yesterday, right? One variable, and you only did one step to solve it. And they look something like this. Is that correct? Well, look what we're going to do today. Instead of having just this, now they're going to add stuff like that. You're saying, oh, man, I remember I started making mistakes with these. So that's what I want to clarify this here. Okay, so writing utensils down, look up to the screen. So this is the simplest way I can explain it is like this. Look up. So let's say one of you decides to buy a nice gift, a nice gift for a special someone. So then you save up all your money from all the chores that you do at home, right? Right. Okay. And so you go and you go to the mall and buy a very nice gift. So here we go. So Yair bought a very nice gift for that special someone, gets back home, and the very first thing he goes and finds a box. So bam, I'm telling you I got this, right? And of course his BFF text him or Instagrammed or kicked them or whatever it is you guys do. And they asked him, so what did you buy? He's on, it's confidential. So since we don't know, he places this gift inside and we're going to label it X. Because what did you cover yesterday? That it was the what? Unknown. Remember that? All right, so there it is. There's the gift. And of course he buys a very nice wrapping paper, places it on the table, and puts the box over the wrapping paper. There it is. And he closes the box, starts wrapping this up. Bam, bam, folds this in, and then he ends up with a very nice wrapped special gift for that special someone with a lot of bling bling. Super shiny. There it is. All right. Pretty good, right? But he's off. Something is missing. So he's off. A bow. But since he forgot to buy the bow, he went to get a shoelace from his shoe. And he's off. Let me lay out my shoelace right here. And then he starts doing like a nice thing like that. And there it is. All right, bam. So he places the bow, and there it is. All right. So far, so good? Yeah? All right. So then he goes to deliver the special gift to the special someone. You get there. As soon as they open the door, there's Yahir with a gift. They look at it like, right? So they're like, wow, you shouldn't have done that. It's because you're special. So, guess what this person did with a gift? Now, be nice. They did not throw it away. They did not do what you guys do when they give you a gift. You just tear everything out and you just want to get to the gift. No, it's a special gift. So this person they started opening but taking everything off very careful because they were going to put that in the frame, the wrapping paper, the bow, the box, everything was going to go on the frame on their wall. Yeah. Really? So if they took everything off carefully, what is the first thing that they're going to take off? The bow. From there, what is the second thing that comes off? The tape that's on the wrapping paper, right? From there, they open the box and they find the special gift. Well, guess what? From now on, I want you to think of the wrapping paper kind of like the operation of multiplication and division. And think of the bow as addition and subtraction. Check this out. And you're saying, what does that mean, Mr. Q? Let me show you. If I give you the equation 3x plus 2 equals 71. Don't write this down, pay attention. Do you see that there's a special gift here, and there's a bunch of stuff wrapping it up, yes? To reveal it, we need to start taking everything off. What was the last thing that went on that we need to take off? The bow. What operation does that represent? Addition or subtraction. Do we have addition and subtraction? Yes, which means I need to take this piece off first. What is the next piece that I'm going to take off? The wrapping paper, therefore it's multiplication and division. Do you see multiplication here? Yes, right here in between there's multiplication. And that's how we're going to be tackling these equations. That's probably the best way that we can explain how x has a lot of operations doing to it, and we need to undo it, going the opposite way. Okay? So with that said, copy this one. We're going to do this one together, step by step, the whole thing, all the way till we check it, and then we're going to do a couple more. Here we go. Bless you. 3x plus 2 equals 71. 3x plus 2 equals 71. Copy that. Example 1. It says solve 3x plus 2 equals 71. All right, here goes the process. First thing I want you to do, to mirror what Ms. V said yesterday and to what I said, the introduction was on equations or the seesaw. I want you to draw a line down the equal sign like so. Why is that? So that it can simulate that we have two sides. Do you guys see the two sides now? All right. The second thing I want you to do before you do any operations and start solving this, I want you to show me what operations are in the equation. So look up. What is this operation? Addition. So you're going to put a little plus on top, so that lets me know that you're saying there's addition. And what operation is here between 3 and x? So you put a big dot to indicate that there's multiplication. So like that, we can remember the gift. You guys remember the gift? So now, where do we start unwrapping this gift? In the bow, which is what? Addition. So what is the opposite of addition? So we subtract 2, subtract 2. This cancels. I want you to bring down the 3x equals 71 minus 2, that's 69. All right? What is the last thing that we're going to take off after the bow? The wrapping paper. What is that? Multiplication. What is the opposite of multiplication? So we divide by 3, divide by 3. And whatever we do to one side, we do to the other. So check this out. X equals 23, Michael Jordan. What? No? No, I'm serious. Have you guys seen in the book that 23 comes up in some of the problems? Yeah. I don't call them like, can you set me some number 23 on some problems? Like, I'm sure. I know, right? I'm telling you. Anyways, now, before we continue, look up to the screen. Write your utensils down. I want you to see the process again. Here goes the process. Line down the equal sign. You're going to show me the operations first that are here, just to guide us. And then we're going to unwrap the gift. Where do we start? At the bow. So what is the opposite of addition? Subtraction. We do that. What is the opposite of multiplication? Division. We do that. And that's how we get to our x. However, I want you to see two things. Look up, please. look at this red bar and look at this blue 1. It's not a bar. Notice the difference. This is a bar, and this is not a bar. It's a what? A 1. Talk it over with your neighbor. Tell them why this is not a 1 and this one is a 1. Talk it over with your neighbor. Why is this a 1? Why is that not a 1? All right, let's see. Molly, why is this not a 1? It's canceling out. How do we know? What is the name of this, guys, that we've been working with since the beginning of the school year? 0 pairs. That's why we cancel it out. However, some of you in the past, when you did equations with just multiplication and division, you guys crossed these out, and you didn't write it. You thought, oh, they crossed out. They canceled out. They don't cancel out. What is 3 over 3? What is 1 times x? X, that's why we write the x here. But I want you guys to show me that you understand that by doing a 1 there. Are we there? All right, so we're done with simplifying, isolating. What's next? Plots. Let's plot our solution. So draw your number line down here. 0, 1, 2, 3, dot, 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 23. And then over here on the side, I want you to write check. And I want you to write the equation, original equation again. Man, look at those beautiful numbers, my goodness. However, when you do the check, this is what I want you to do. From now on, anytime you see a variable, I want you to open a parenthesis. Open a parenthesis, and then bring everything else down before you substitute. This is 3 plus 2 equals 71. All right, so now let's substitute. What goes in for x? 23, Michael Jordan. So 23, that's what we got for x. So let's simplify this. What is 3 times 23? 69 plus 2 equals 71. What is 69 plus 2? I'm working on this side only. 69 plus 2 is 71. Is 71 equal to 71? Yes, and that's how we check. I want to see this in the home plate tonight. Here we go again. Simplify, isolate, plot, check. Simplify, isolate, plot, check. Simplify, isolate, plot, check. All right, we got this? Do this next one by yourself. Here we go. Still part of example 1. Write it right underneath. Negative 5x plus 12 equals 37. Negative 5x plus 12 equals 37. See if you can do that one by yourself all the way through, all 4 steps. Copy that and go. All right, check with neighbor, see what they got. All right, let's see. What'd you get for this one, Julian? Oh, did you guys hear that? Yeah, if you say negative 5, that is incorrect, because negative 5 is a numerical expression. However, Julian said x equals negative 5. That is a equation. Hands if you got that. That is correct. And once again, the process is as follows. Line down the equal sign. You need to indicate the operations that we have, multiplication and addition. From there, you do the opposite, and you start with addition. So subtract 12, subtract 12. We end up with negative 5x equals 25. The last step is the opposite of multiplication is division. Divide by negative 5, divide by negative 5. You indicate here the giant 1, and that's how we get x equals negative 5, yes. Very good question, and we're going to get there. All right, let's plotting it. So we got 0, 1, 2, 3, 4, 5. That's negative 5. You plot your answer, and then we check. We got negative 5, parentheses, negative 5x plus 12 equals 37, plus 12 equals 37. But we substitute which value? Negative 5. What is negative 5 times negative 5? 25 plus 12. What is 25 plus 12? 37. Is 37 equal to 37? Yes. How are we doing? Yes? Okay, show me with your fingers how comfortable you are so far with these. 1 being the lowest, 5 being the highest. Okay, not bad, not bad. All right. Don't copy these. I want you to copy this next one. Example 3. This one. 8 minus A equals 14. 8 minus A equals 14. Example 3. We're going to do this one together. Don't go fast because this one has a little curveball. Let's see if you caught it. Here it goes. Line down the equal sign. Okay, let's see. Where's my variable? My variable is right here. What's next to the variable? A 1. Very good. So therefore, what operation is next to the A? Okay, this is a 1. Is that correct? And it becomes a -1. So what operation is next to the A? Multiplication. -1 times A. All right? What sign is invisible in front of the 8? Plus. All right, so now we have our operations. Where do we start? With where? With addition or subtraction, right? So here's addition. So what is the opposite of positive 8? -8. -8 to each side. We're left with -1 times A equals 6. And our last step, divide by -1, divide by -1, A equals -6. And you know what to do the rest. You don't have to do the plot and the check. Let's just leave it right there. Did everybody see what happened on that one? Okay, let's see if you catch it again. Here he goes. Do this next one by yourself. $12 minus A equals 27. Let's see what you get for that one. Go. All right, check whenever, see what they got. All right, everyone, A equals, that is correct. Once again, make sure you draw your line down. Here you put a 1 here, and if there's a number in front of the A, there's multiplication. This one's a positive 12, so that means it's addition. So we start with -12 minus 12, -1A equals 15. Divide by -1, divide by -1. Therefore, A equals -15. So far, so good? Yes? Copy this next one, please. -3 equals M over 4 minus 6. -3 equals M over 4 minus 6. Let's do this one together. Let's not plot or check. Let's just solve it. Line down the equal sign. What's happening here to the M? What operation? Division. So write it above so that we know that there's division. What other operation is on that side? Subtraction. So where do we start? So what is the opposite of subtraction? Add 6, add 6. This cancels. So what is 6 minus 3? 3. Bring down the M over 4. And what operation was this? Division. So what is the opposite? Multiply times 4. Multiply times 4. Look what I'm going to do here. Look up. What did I do? A giant 1. Do you guys see that? So 1 times M is M, and that is equal to 12. So we have 12 equals M. Now, why was I able to do this? Let me show you over here on the side. M over 4 times 4. If I put 4 over 1, this becomes M times 4 is 4M. 4 times 1 is 4. And what is 4 over 4? 1. Do you guys see that? That's why I was able to do this right here. Yes? Let's do one more. Do this one by yourself. -7 equals M over 9 minus 12. After that one, we have one more, and then we're done. So act like tomatoes, please. like tomatoes. Get it? Yeah. Yeah. Or don't forget to drink your orange juice at home, because it's made out of concentrate. There you go. I didn't understand. Hands, if you're done. Okay. Tell your neighbor what you got, please. All right, let's see. What'd you get for this one? Jesus. 45 equals M. Hands if you got that. That is correct. If you wrote M equals 45, I'm going to take a point off. Make sure you leave the M where it belongs. Okay? All right. Next, copy this one. Yay. Example 4. That looks really easy. 2/3 R plus 3/4 equals 7/12. Audrey, copy that. My goodness. Oh, you did? Yeah, you're pretty quick. All right, here we go. Writing utensils down. Look up to the screen. Check this out. You're saying, Mr. Q, now there's a bunch of fractions. Yeah, but you guys love fractions, right? Yeah. However, let's say we didn't want to work with fractions. Let me show you a process to get rid of the fractions. Look up. First of all, look at the denominators. What is my common denominator for all three? 12. I would take that 12. Pay attention, please. Okay, I'll wait. Ready? Here we go. I would take the common denominator, which is 12, write it outside in parentheses, so I'm going to multiply times everything inside. But since all of them are fractions, I'm going to write 12 over 1. 12 times 2 is 24. 1 times 3 is 3R. 12 times 3, that's 36. 1 times 4 is 4. 12 times 7, that's 84. And 1 times 12 is 12. You're saying we still have fractions, Mr. Q. I know. What is 24 divided by 3? 8R. Plus, what is 36 divided by 4? 9. And what is 84 divided by 12? 7. Do you know how to solve these kinds? Yes. Copy that. And you know what to do from there. You draw your line down, write your operations, and so on and so forth. Yes. The home play is over here. Home play for tonight is play sheet. Play sheet 2-2. Only do numbers 1 through 16. 1 through 16. Only. Yes, today's special. Yay. All right, guys, enjoy your home play. Pick up a play sheet from the front. As soon as you're done, have a good one. See you guys tomorrow. Bye.